Hi there, folks. Today we're looking at graphing categorical data. The first method for graphing categorical data that we're going to look at is the bar graph, okay? Bar graph essentially just shows each category as a bar, an individual bar, where the height of the bar is the frequency or relative frequency of that particular category. And keep in mind, when we say frequency, frequency is the count. There's a very slight difference between frequency and relative frequency. Frequency is the actual count when we count exactly how many of that thing there are. And the relative frequency is when we write that as a percentage, okay? So again, they pretty much represent the same thing, but in a slightly different context, okay? When we go straight frequency, we're just talking about the actual count of that data. When we're talking about relative frequency, we're talking about the percent of that piece versus the whole thing. Bar graphs are typically the best option for displaying categorical data. The other method that we'll look at is pie charts, and they can be very problematic, but they have their place. All right, so best option for categorical data is the bar chart, the bar graph here. Values on the y-axis should start at 0. We don't want to start that at just any old value. We want to show a very direct comparison between these things, and so starting at 0 is very important. So when we look at this, we're just going to go ahead and draw a bar graph of this. And just to simplify things a little bit, we're only going to do one of these. Let me get rid of this guy right here. And we'll just do the starting salary of each of these things. So we can see that, I guess, starting salary for a teacher wasn't included there. I guess someone didn't want to discourage people from going into the profession. So when we want to create a bar graph here for each variable, again, I'm just going to start by setting up kind of like an XY coordinate plane. And down along the bottom of this thing, I'm going to put the different categories for my categorical data. A lot of times we'll kind of draw this, I don't know, kind of written like vertically like this. So business administration, then it was nursing, I think. And the only reason we're writing this sideways is just to kind of conserve space a little bit. If I tried to write this out horizontally, it would just take up too much room. A little sloppy me trying to write sideways here, okay? So those are the categories we have when we scroll back up here. I've abbreviated all of them. And then off to the side here, we just have to create a scale that, again, starts at 0 and at least goes to the highest one here, which looks like the 53,000, all right? So I might go by, I don't know, like 10,000s or so. So this would be 0. This would be 10,000, 20, and 60. Okay. And now I just draw a separate individual bar for each of these. So business administration was 41,000. So I draw a bar that essentially goes to a height of 41,000. Nursing was the next one at 53. And again, we want space in between these bars. These are individual categories. They're not connected in any way. Unlike a histogram that you might have done in like algebra, histograms have to be connected, and we'll do histograms a little bit later in this course. But these are separate categories, and so we show them as separated when we draw our bars, okay? Liberal arts was at 36. Psychology, 35. Bio, 37-ish. Criminal justice at 35 also. Accounting at 44. Communication at 37. And English at 36. The other thing you'll notice is this kind of looks like a mess when I look at that like this. One of the things you should always do is maybe shade in each of these bars. It just makes it a little bit easier to read, even if it's just kind of just doing one of these guys, okay? It just makes the readability of this thing so much better in terms of looking at those individual bars. When we have those bars not filled in with anything, I don't know, our eyes kind of play tricks on us, and it just looks like a bunch of lines. Filling them in with something makes this just a little bit easier to read, okay? And if you have some colored pencils or a crayon, you can go ahead and shade those in with that if you'd like. Okay, but again, it just makes it a little bit easier to read. And again, just gives us a very quick side-by-side comparison of these things in terms of what the differences are in terms of the starting salary for these. Okay, and that's it. We look at something like this guy. It says, why is the following bar graph deceiving? And again, one of the things with statistics is it's really easy to kind of skew these things to misrepresent these things. And this is a great example of that. When we look at something like this guy, like if I were to look at this bar graph at face value, it looks like this is comparing number of students and their favorite subject. Okay, so how many students said English was their favorite and how many said math. When we look at this, it looks like there's about twice as many students who prefer English over math. In fact, like looking at like foreign language, it looks like, I don't know, there's like 12 times as many students who like English as opposed to foreign language. And that's really a huge misrepresentation. That's not true when you look at the actual numbers. Math is around 180 and English is around 260. So it's less than 100 values difference. It's not double. All right. And the reason this is deceiving, the reason it looks like it's double, is because right here, this graph does not start at 0. And so what it does, it kind of skews the results. It makes these differences appear greater than they actually are by not starting at 0, okay? So the explanation I would say here is the differences look larger, so the differences appear to be bigger. And so those differences appear larger because the graph doesn't start at 0. In fact, we can kind of imagine this thing. If you were to start at 0, it would make the bars look more like this. Like this guy would be actually down here quite a bit. So all these bars would actually be much, much bigger. And you see, it kind of shows you a better representation then of these comparisons. Okay. Now all of a sudden you're like, oh yeah, English is not twice as much as math. It's not 12 times as much as foreign language. It's a lot closer than it first appeared. Okay. The second way to display categorical data is using a pie chart. This shows the categories as slices of pie that are proportional to the frequency or relative frequency. And really with pie charts, we almost always use the relative frequency. We almost always use that percent instead of the count. Bar graphs, you can use either one, but pie charts, typically we're going to do the relative frequency, okay? Data must be represented as parts of the whole when we do this, which is why a percent makes so much sense. It's acceptable for categorical data, but can often be misused. It's one of those that just is overused. They're difficult to create. They're difficult to read at times, and there's a lot of estimation involved, okay? Typically doesn't show as much accuracy. And again, they're overused and kind of abused a little bit, all right? For example, we want to create a pie chart from the data below. Again, this is the other half of that data that we used above that I didn't use for the bar graph. And so one of the things when we first set this up is first thing, we've got to convert all of these to percentages, okay? And if you forgot how to do that, remember we've got to add all these up. So if you add all these up, you get a 953,000. And then what you have to do is you have to take each of these, like I would have to take this 180, divide it by the 953,000. That gives me the decimal. I multiply by 100 or move the decimal point 2 places to convert that to a percent, okay? And so I've already done all of these, and so I will write each of these as a percent, okay? 19%, 16%. Let me just write these down. 15%, 12, 8%. This one also ends up being 8%, even though they're a little different. So you can already see some of this not being quite as accurate. Both of these are going to be 6% when I'm rounding to the nearest percentage. Okay, so it is going to require a little bit of estimation. This one's also rounds to 6%. So it's not really showing a distinction between those, even though we know there is a distinction. Okay, so again, it's not quite as accurate. It's not quite as precise as what we can get out of a bar graph. Okay. And so now the other tricky part of this is I have to draw a circle, which can be a little bit tough. Okay. So I'm going to draw a circle. Actually, I do have my shape tools here, so I'm going to use that to draw a nice circle for myself to make it a little bit easier. But now I still have quite a bit of estimating to do, okay? When I go to draw this thing, I have to try to make each slice of pie proportional to the percentage, okay? And so when I do this, like I might start here and say, okay, let me draw that guy. And so 19%, I have to make that about 19% of the circle. Well, that can be a little bit tricky to estimate, okay? And so I might call this 19%, and that's going to be business administration, okay? And then the next one, I need 16%. So it's got to be smaller than the 19, but okay. And what happens a lot of times we get to the end and our slices are too big or too small, and we have to go back and redo some things and change some things. So 15% for this one. A little bit smaller, 12%. We can already see like we've lost a bunch of accuracy as we went here. The other thing is, as I'm finishing off these last couple, there's no standard here that says that I have to write the percentages in here. Sometimes people will just put the categories in, and it's kind of up to us to interpret. Sorry, my screen went a little funny there. It's kind of up to us to interpret what percent that actual piece of pie represents. Like I'm writing the percentages in here so that we can kind of see them. There's nothing that says I have to put that in there. Teacher education. And look at that. I already lost a bunch of accuracy. There's another 6%. And then this one's the 4%. Okay. So again, I should have drawn my circle maybe a little bit bigger. My percentages got a little crammed as I got towards the end of this thing. But I've done my best. Yeah, I can kind of tell that, yes, the biggest slice of pie is the 19%. The smallest piece of pie is the 4%. If I really wanted to make this accurate, I'd have to bust out my protractor, and I'd have to take the 360 degrees and multiply that by each percent and figure out that, okay? And so these are not typically very accurate. We're doing a lot of estimation because to make it accurate would be a real pain, okay? And again, yeah, I can kind of gives me an idea of the data, but it would have been much easier to do a bar graph, and the bar graph would have had a lot more accuracy to it, okay? If we look at something like this, what's the issue with the pie chart below? Well, the first thing you should know is they should all be parts of a whole. Well, if these are all parts of a whole, it means that the percentages always have to add up to 100%. And so when you look at this bar graph, this pie chart is completely inaccurate, where we've got 70%, 63%, and 60%. Well, those didn't even add up to 100%. And so is that 70%, 70% of the circle? No, because half of the circle would be this, right? That would be 50%. So I have a 70% only taking up about a third of the circle. It doesn't make any sense, okay? And so somebody took some data that maybe somebody supported more than one candidate and said, okay, they support both of these. And this was not a good idea to use a pie chart for this. So with a pie chart, it has to be values out of the whole. So these don't add up to 100, which is a real problem for us, okay? This pie chart does not make any sense, and nobody caught this. It doesn't mean that the data is not accurate in some way. It just means that it's data that can't be displayed in a pie chart, and they should have used something else. Okay?